This program is about writing classes, and we'll go over many features, more features of the class, objects, and how a basic structure of a program should be, and this is going to be a little bit more expanded version. All right, so in the bank account.java program, which is on Schoology, I have put notes. First several lines are notes. We'll go over them real quick, very quickly. So kind of like I'm teaching from home, but really not. All right. So a class is a blueprint of an object. It has no memory space. Each object that you create from the class has its own data space. Thus, it has its own state. The scope of a variable, all right, which determines where it can be referenced, depends on where it is declared. There's class level variables and there are local variables. Objects should be encapsulated. The rest of the program should work with an object only through a well-defined interface, and we'll talk about what those interfaces should be. This is basically objects like today, bank account, should be protected from being hacked. All right, so it has to be protected, encapsulated. Instant variables should be declared with private visibility. This is in the spirit of encapsulation. A return value, something that's being returned, must match the return type in the method header. So if it's void, it returns nothing. If it's string, it must return a string. If it's a double, it has to return a double. When a method is called, the actual parameters, which I'll show you in this example today, what an actual parameter looks like, are copied into the formal parameters and then used in the method. Now they have to match also. If a method needs a string, you have to give it a string. A precondition is a condition that should be true when a method is called. Something needs to happen ahead of, something you should happen ahead of time. I mean, if you're going to make chocolate cake, you need chocolate. A postcondition is a condition that should be true when the method finishes. If you're going to bake a cake, this method is going to bake a cake, you would expect when you're all said and done that you would have a cake. All right, a constructor cannot have any return type, and we'll go over that. A constructor doesn't return anything, so doesn't have a return type. Constructor creates an object. A variable declared inside the body of a method is local to that method and cannot be used outside of that method unless it's declared, and then it's actually a different variable. Could be spelled exactly the same, but it's a different variable. Most objects contain accessors, which I like to call our getters, and mutators, which are setters. Accessor, you get information. A mutator, you set information. These methods allow the client to manage the data in a controlled manner. All right, today's example is going to be a bank account. We're going to keep it simple. We're going to do some instant variables. Every bank account, as a minimum, has these three things. It has an account name. It has an account number, and whether you like it or not, every account has an account balance. Your balance might be 0, but it's still a balance. Now, even on line 48, we're going to create a constructor. Every program that you write in Java has a default constructor, even if you don't write it. This constructor will have information for each one of these class level variables. These class level variables, now that we've declared them, can be used anywhere in the entire program. So I'm going to write the default one, public. Now there's no return type. And now, a constructor is a special method. Every method in Java has parentheses, whether there's something in them or not. If you see parentheses at the end of an identifier, which this is an identifier, it's the name of the constructor, you know that it's a method. This method, notice here between the C and the B, there's no return type. So in this case, we're going to initialize account name and we're gonna, how about John Doe, and we got an account number. I'm gonna be super duper creative. This is actually not a number. This is actually a string. Can't do math with an account number. You don't add one phone number to another phone number to get a third phone number. Those are actually strings. And then we got a balance. So how much should this balance be? Let's give him $1.75. So every object that you make with this constructor will have John Doe 123 and $1.75 in it. Those are the three things it'll have in it. Now, what if you want to customize? All right, you want to customize the object you make. You don't want it to always be John Doe. All right, so when you make a bank account, here's a post condition. This is something you must expect with every account. Once an account name and account number has been established, you don't change it. If you want an account name to be different or an account number to be different, you would close one account and reopen another one, which means you'd make a new object. So in this case, our assumption is once we've made an object, we're not going to change the name and we're not going to change the number. The only thing that does change is the account balance. It goes up and down. So here is our overloaded constructor. Now, it's overloaded because notice line 48 and 59 have exactly the same name. Overloaded means it has exactly the same name, but different input. Now this input that we're going to request, these are called formal parameters. Formal parameters, you have to have a data type, and we're going to say name. Now also, please note that the different parameters, formal parameters, are separated by a comma. And we got string count and double balance. All right. Name, account, balance. Those are the three names of the incoming formal parameters. They are local. They only exist within this method, within this constructor. We could use name, account, and balance elsewhere, but we would have to declare them again. We'd have to declare them a second time. Not like these three. Account name, account number, account balance. Those are class level. Those are instant variables. All right, so in here what we're going to do is we're going to assign, when we use this object, our account name is going to get name. Whatever we say it is, our account number is going to get the account number we give it, and the account balance gets balance. Now, when we use this constructor, the constructor on line 59, we can determine what the name is, what the account number is, and how much their starting balance is. So this is an overloaded constructor. All right, so now let's go to the methods. We're going to do some accessors. We want to get information without changing anything. A lot of times you go to the ATM machine and you want to know how much money you have because you're going to go on that hot date with your significant other, and you want to know you have enough money in the balance. So you just do a query. You ask, how much is my balance? And it tells you. But to ask, you're going to have to give it a name and an account number. Or you use your debit card or your credit card when you stick it into the ATM machine, which has your name and account electronically stored on it. All right, so here is our accessor. All right, so we want to be able to get the name. So public string get name. So get name. What do you think get name does? It gets the name. It retrieves the name from our object and it returns it. Now, because this method header has a data return type, we have to return the same data type. So we're going to do return, and we're going to return the name of our account, which we know is a string. So it's going to return the name. We're going to do the same thing. You should do a getter for every single instance variable that you create, so you can get that information and use it. And here we want to get the account number, so this is going to return account number. So this we can ask the system to give us the account number. Now we also have to get the balance. Notice this one's a double. All right, so we return account balance. All right, so account balance is a double, so our return type is a double. So these are all our accessors, our getters. We have 3 instant variables, so we have 3 getters. Now our mutators, just like a mutate means to change. So we're going to set values to a new value. So now there's only 2 setters that I want to do. I don't want to be able to change a name, like I said before, and I don't want to be able to set a different account number. Because once I establish a bank account, the name stays, The account number stays. The only thing that changes is the balance. So I have a precondition here. A precondition. In this case, my precondition is that what I want to do is I want to deposit some money. So my deposit, I'm assuming my deposit is going to be greater than 0. You don't deposit nothing. That would be a waste of time. So my precondition is depositing. So public void. I'm not returning anything. I'm changing something. So I'm not returning anything, so you use the word void. And here it is. I'm going to call this deposit money. All right. In this case, I'm putting a formal parameter, and I'm going to call it deposit. Here, I'm actually changing the instance variable. So my account balance, I'm going to add onto it deposit. So if I'm going to deposit $200, the $200 is going to be added to my account balance. And then we're just assuming that it was actually added. But if we were unsure and we wanted to check, we would go and use this public double get balance to see if it changed. In our tester, we're going to try this. All right. The other mutator I want to do is when we take money out. All right. So once again, we have a precondition. All right. My precondition is that the withdraw, whatever I withdraw, is less than or equal to our account balance. Okay? So we have to handle this precondition in our thing correctly. All right. So here we go. Public void withdraw money, and then we have double how much we're going to withdraw. All right. Now, how can we tell whether this precondition is true or not? Well, we would have to use a conditional statement, like we did in Unit 3. So if withdraw is less than or equal to account balance, then we're going to do what? We're going to do account balance. It's going to be minus equals withdraw. Else, we could say something like system.out.println insufficient I can't spell it right. Insufficient funds. Alright, so when we call upon this method and withdraw is more than account balance, then this is going to be false, and it's going to type insufficient funds. Alright, so that's the end of our mutator. So let's compile, make sure everything's fine. Okay, everything's fine. So now let's do a quick tester on the next video.